The slope of a tangent to a curve. At first, what is the tangent? The tangent at a curve is actually the derivative, and it's very important because it can tell us the behavior of the curve, whether it is climbing if the derivative is positive, if it's negative it's diving downward, or if it's parallel it means that the curve at this point, the tangent is parallel to the x-axis. It's leveled, just like if you imagine it an airplane. When the tangent is zero, when the slope of the tangent is zero, it means that the airplane is neither climbing nor diving. It is in a leveled flight. So what is the slope at a specific point? Is tangent or tan theta, which is the rise divided by the tread. So what is the slope? This height, which is fa plus h minus fa, y of a plus h, which is a step by the way, minus y of a, which gives you this elevation here, divided by h, which is not the height. H is the step. It is the tangent, which is height, divided by the tread. Let's write the function that will return the slope. Double f slope a double b double c. These are the same parameters for the polynomial equation x, and we need the step, which is the value of h by the way. Return rise over tread. So polynomial equation of a, b, c, and x plus step. Here we need, by the way, the forward minus the backwards. So going back to this function, we need this one minus this one to see in the progression of the curve from that point forward if the curve is actually climbing or diving. X plus step minus polynomial equation a, b, c, x divided by x plus step minus x, which is the same thing as saying divided by step. So let's call it. We're going to use the same function y equal x2 double slope is equal to f slope 1 0 0 0 at x equals 0, and the step is 0.0001. Print f slope of y equal x2 at 0 is percentage f slope. You get 0, around 0, okay, not exactly, because you need to be 100% almost accurate, meaning exactly at 0 to get 0 sharp. However, this tells us y equal x2 would be parallel, the tangent over that curve would be parallel to the x-axis at x equal 0. Let us try for another value, and I want to change the code to add some few conditions. We will try x equal 3, and let's test the slope. So if the slope value is greater than 0, then I want to print that the function is climbing. Else, if slope is less than 0, function fx is diving downwards, means that it is going down. Else, function would be parallel. It won't be changing levels. The tangent would be parallel to the x-axis. Print fx is leveled and parallel to x-axis. And you notice that the slope of y equal x2 at 3 is 6, which is positive, greater than 0. And since it is greater than 0, the curve is climbing upward, which is the case, by the way, exactly for y equal x2. Because if you look at the function, it is at x equals 0 parallel. It changes curvature because it would be going down. Then it starts going up right after 0. So 0 is the level. Then right after 0, it keeps climbing to plus infinity.